The next unit is all about statistics, and we're going to begin with some basic dot plots and histograms, which I'm sure you've seen before. But a dot plot is a plot of each data value on a scale or a number line. So here are 3 different dot plots, and you can identify the shape of a set of data. The shape of a dot plot can either be symmetrical, like this one, means you could kind of fold it in half, it'd be the same on either side, or skewed. These two are both skewed. So most of the data in a symmetrical dot plot is near the center of the range. This shape is symmetrical, okay? So let's underline that, symmetrical. Okay. These two, the dot plot has a tail on the left, so it goes up like this and it tails off this way. So it has a tail on the left, so we call it left skewed. And this one goes up on the left and goes down on the right, so it has a tail on the right, so we call it right skewed. This one goes up in the middle. There you go. Okay. Now they don't have to be perfectly symmetrical, but mostly having the highest value in the center somewhere would be symmetrical and tailing off on either side. The mean and the median of the distribution are numerical summaries of the center of the data distribution, so the mean and the median. Now, when the distribution is symmetrical, the mean and the median are approximately equal. When the distribution is not symmetrical, like these two, we call skewed, then the mean and median are not the same. Okay, so for a symmetrical distribution, the mean is an appropriate choice. So symmetrical, you would choose mean to describe the typical value. However, for skewed, the median is the better descriptor of the value, so of the typical value. So that's very important. Symmetrical, we use the mean. If it's skewed on either, then we choose the median. Median for these two, mean for this one, okay? So let's start by making one. This one is students from River City High School were randomly selected and asked, how many pets do you currently own? The results are recorded below. So make a dot plot, and you want to actually make an accurate dot plot, then you need to make sure that when you make the dots, you evenly space them as best as you can. Okay, now I say as best as you can, but it can be difficult. So we can see that the mode is 1. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the mode 1 occurs 10 times. So here's where 1 would be. You don't actually have to put the 1 in there. I'm just showing you. We've got to fit 10 in here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now when we do the others, we have to space them out similarly. So 0 has 1, 2, 3, 4. 1, 2, 3, 4. 2 has 4 of them. 1, 2, 3, 4. 3 has 2. And don't forget, it's going to go here. 1, 2. 4 has 1. Woo! 5 has 2. 1, 2. 6 has 2. 7 has 1. 8 has 1. 9 has 1. 10 has 1. And 12 has 1. So there's your dot plot. And you can see the shape that's going on here. Okay, so if you had to draw it, how could you describe the distribution of the number of pets owned by students at River City High School? Would it be symmetrical, left skewed, or right skewed? Okay, so let's imagine it's going like this. So the highest value is towards the left, but we don't call it left skewed. It's not based on the high value, it's based on the tail. So if the tail is on the right, then we would say that the distribution is right skewed. There we go. Okay. Because the tail is on the right. We'll say that. Because the mode is on the left and the tail is on the right. Good. All right, next, calculate the mean number of pets owned by the 30 students from River City High School. Calculate the median and also. Now, there are a couple ways you can do this. Now, when you can go ahead and add all of those individually, but I kind of like to take a shortcut, and I'll describe that to you. So if we have 4 values that are 0, 4 times 0 is 0, okay? We have 10 values that are 1, so 10 times 1 is 10. We have 1, 2, 3, 4 values that are 2, so 4 times 2 is 8. 2 times 3 is 6. 1 times 4 is 4. 2 times 5 is 10. 6 times 2 is 12. And then we've got a 7. We've got an 8. We've got a 9. We've got a 10. And we've got a 12. So rather than add them all individually, now the problem with adding them all individually is you sometimes can lose track. So if you are going to add them all individually, I would suggest you make a little mark once you've put it in so you don't skip one, especially when you get to those 10 ones. So I like this because it's a little easier to be sure that I've included every single number. And this will come in handy when we do histograms as well. So once we know what each of the single data values add up to, then we can add all of them together. These are called the frequencies. So add all of the frequencies together and to find the mean. So of course you know that the mean is the total divided by the number of values we have. So we know we have 30 students, and when we add all of these up, we get 96. So when we divide that, 96 by 30, we get 3.2 pets. Usually we want to round to one more digit than the actual data values. So since the data values are a single digit, we're going to go one place past that. That's usually the rule of thumb. Okay, so this is the mean. The median, of course, is the middle value. So maybe we don't have that defined anywhere here, assuming that you already know the mean and the median. But the median is the middle value. So if we have total divided by number of values, let's do that. Okay. So the median is the middle value. Okay. And so if we have 30 values, we divide that by 2, which gives us 15. Now that means we have 15 on each side of the middle. Okay. Now imagine if we have 15 on this side and 15 on this side, then the middle value would have to be between the 15th and the 16th number. So we need to find what the 15th number is and what the 16th number is, and then we're going to have to average those. So let's see, counting up from the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the 15th value is 2, and the 16th value is also 2. So that makes that very simple. So the average of 2 2s would just be 2. So we have 2 pets. Okay, so we know it's going to be between the 15th and the 16th. So normally what you would do is, since the 15th is 2 and the 16th is 2, you would add them together and find the average of those 2 middle numbers to find the middle number. Okay, let's go to the next page. What do you think is a typical number of pets for students from River City High School? Explain how you made your estimate. Okay, now we decided that this was right skewed, and if you go back, remember we said that if it's skewed either way, that the median is the better choice. So the typical number of pets for students from River City should be, since it is skewed, then we use the median, which we just determined was 2 pets. Explain how you made your estimate. But we really didn't have to estimate it because we had already calculated it. So the median's a better number. We just described the median is a better choice because the distribution is skewed. Okay, excellent. Now a histogram is very similar to a dot plot, except they have bars. So a graph of data that groups the data based on intervals and represents the data in each interval by a bar. Now technically in a histogram the bars are touching each other. If the bars don't touch each other, then it's called a bar graph. You usually use a histogram for what we call numerical data, numbers. You would use a bar graph for categorical data. So if you want to say favorite color, we've got red, green, blue, yellow, and you're going to write categories down at the bottom. We use a bar graph, so they're separate from each other. But if we're using numbers from 0 to 450, then we would use a histogram, okay? So use the histogram to the right to answer the questions. Now, we want to calculate the mean. And this is going to be very similar to the dot plot that we just looked at, okay? But we might want to do some things to get us closer to finding that. So first thing you might want to do is actually determine how many. So we're talking about the money spent on soft drinks per month, rounded to the nearest dollar. And this is the frequency of responses. So what this means is that 19 people said that they don't spend any money on soft drinks, okay? And then we have to figure out what these increments are here. So if this is 75, then these must go up by 25. So this is 25, this is 50, this is 100, 125. And you can fill those in if you want. That makes it a little easier. 175, 200, 250. You don't have to fill them in. As long as you know what they represent, then they don't need to be filled in. Now, here we've got halfway between 16 and 18, so this is 17. So why don't you go through each of those and determine how many you have of each. So go ahead and pause the video. Okay, now let's see if we have this right. You should have 15 here, 15 here, 10, and 7, 6, only 1 here, 5, 3, 1, and 1. Okay, so now we want to use that multiplication skill. So this, unless we're going to list out all 17 of these and all 15 of these, then you want to use the shortcut that I taught you on the dot plot on the previous page. So we're going to multiply these together, okay? And we can go ahead and put them down here if you want, or we can write it across here. That would make more sense. So if 19 people responded that they spent $0, then 19 times 0 would be 0. That's a different color. So that's 0. 17 times 25 would be 425. 50 times 15 would be 750. And I want you to go ahead and pause the video and calculate the rest of those with your partner. All right, now let's see if you have the rest of these right. So this one should be 1125. This should be 1000. Then we've got 875, 900, 175, 1000, 0 of course there. And we've got 750 here, 275 here, and this one would be 425. Okay, so when we add these frequencies together, we are in fact actually multiplying them to find how many are in each classification, in each interval, okay? Now to find the mean, we'll do the same thing. We will add all of these together. So we get 7,700. And it doesn't tell us in the description, there really isn't a description of how many people there are. So we need to add the intervals. So 19 plus 17 plus 15 plus 15, not the intervals, the frequencies, I'm sorry. So we add the frequencies together, we'll figure out how many people actually responded in this survey. So when we add all of those together, you should get 100 people. So this is the total of the frequencies. Okay, these numbers. So another good reason to actually write these in. That's going to make everything much easier. And then 7,700 is the total when you multiply it by the interval. Okay, frequency multiplied by the interval. And so when we divide that, we get 77. So that would be $77 per month spent on soft drinks. Yowzers. Would you describe your graph as symmetrical or skewed? Hopefully you're thinking it is skewed. So it's high on the left and goes low on the right. So we call it right skewed because the tail is on the right. Okay. The mode, of course, is the one that occurs the most, so that would be $0 per month. And make sure you don't name it 19. 19 is not the dollars spent, that's how many people, that's the frequency of times that people said they spent $0. And then the range of the data, well, the lowest value is 0, so it goes from 0 to the highest value, which is 425. So we really do 425 minus 0, so we get the range is $425. Okay. Last example, find the measures from the histogram. So I want you, we're basically doing the exact same thing we did on the previous problem, except for the median. Okay. So I want you to pause the video and see if you can calculate the mean, the mode, and the range with your partner. And then I will show you how to get through the median together. All right, so the mean, in order to find the mean, we have to do the same thing where we put the totals in here. So we've got, this is 5, 9, 4, 1, 2, 2, 2. Okay, so to find the mean, we're going to multiply the number of books read per week times how many people said that they read that many books. So 5 people said they read 0 books. So 0 times 5 is 5. 9 people said they read 1 book. So that would be 9. 4 read 2. So that's 8 books total. 1 person said they read 3. 2 times 4 is 8. 2 times 5 is 10. And 2 times 6 is 12. Okay. So the next thing you want to do is add those all together. And we get 50. Now to determine what we're dividing by, you add these bottom numbers together. Okay? 5 plus 9 plus 4 plus 1 plus 2 plus 2 plus 2. And we get 25, which is good because it says right here, the histogram shows the distribution of the number of books read by 25 college students. So sometimes you don't even have to add those up. You can simply check the directions. Okay? Might be good to do both so that you make sure that you have these values right. So when you're multiplying by them here, then you know that you're using the 25 and that they match up. So we get, of course, two books per week is the mean value. Okay. The mode, of course, is the highest one, the most. So that would be 1 book per week. And then the range is highest value is 6, lowest value is 0. So 6 minus 0 is 6 books. Okay. We don't want to say per week because that's a range. That's just, we're not asking for a measure of central tendency. Now the median's the more challenging one, okay? We know we're looking for the middle value, and it's not as easy in the dot plot for you to figure this out. So we know we have 25 college students. So we need to take those 25 and divide it in half, which gives us 12.5, okay? That means that we have 12.5 values on each side. So imagine if we have 12.5 on this side and 12.5 on this side, really you can't have half a value on the left side. So it's really the 13th value that we're looking for, okay? Now here's how this works. Always start from the bottom, okay? We have 5 values in here, 1, 2, 3, 4, 5, and we have 9 here. So we go 6, 7, 8, 9, 10, 11, 12, 13, 1, 2, 3, 4, 5, 6, 7, 8. Yep. So when I find the 13th value, I'm still in this bar, I guess, because the first 5 were here. 1, 2, 3, 4, 5. And then we kept counting, and when we got to the 13th value, it was here in this bar. So that means that the median is 1 book per week. Now let's say this was the 17th, okay? Of course it isn't, but let's say it was. Then you would go up to 5 here, and then you would add your 9 here. That would bring you to 14, and then you'd be here 15, 16, 17. So then you would be in here. So you want to make sure that you're counting from bottom to top. Technically you could go from top to bottom as well, but I always count from the bottom up. All right, and then you also have a question here. What percentage of students read less than, less than 3 books? Okay, so first of all, if it's less than 3 books, we know we're talking about this bar, and this bar. So don't include 3 because that would not be less than 3. So out of these 25 college students, okay, we add these together. 5 plus 9 is 14 plus another 14. This means there's 18 people represented here out of the 25. Okay, so we're just adding 5 plus 9 plus 4. So 18 divided by 25 is 72%. So 72% of the students read less than 3 books.